Hello, morning. So today we're going to do the next part of trigonometry, and then we'll be done with the chapter. So before we get started, do you guys have anything you want to ask from the exercise that I've given you? If you do, just send me a message on WhatsApp, and I'll go through the question. Okay, I haven't gotten anything yet, so I will get started. All right, let's go. So, um, let's say I give you something like, how should I write this? Let me think. Let's say cos theta plus sine theta equals to 3. Or maybe cos theta plus sine theta equals to root 2. Okay, maybe I'll call this 2 sine theta. And then I ask you to solve something like this. What do you do? Well, if you get rid of cos theta or 2 sine theta, it's pretty easy to solve because you just solve it normally, right? However, when you have two functions like that, you are kind of stuck. If you have cos squared theta plus 2 sine squared theta, you can actually use the basic identity to convert either cos to sine or sine to cos, and then everything will be in one term, either in terms of cos or sine, and then you can solve it. But this one, there's no square, so you can't actually convert it. I mean, technically you can, but you get like a square root, which is not going to be of much help. So what you should do when you have something like this is by doing this. So imagine you have r times cos theta plus alpha. Okay, you don't have to start with cos. You could start with sine. Usually the question will tell you which one you should use. But let's say for this question, we'll start with cos. So we're going to use the addition formula and expand this. We're going to get r cos theta cos sine sine, right? Cos minus sine sine. And then we're gonna multiply this in. By the way, this alpha is actually just some constant. This is actually a constant. Okay, so you can see that I've arranged it like that. This guy here is actually a constant, and this guy is actually a constant. This r is also another constant. So if you compare this with what we have over here on the left, you'll see that r cos theta must be 1. And negative r sine theta must be 2. Okay, so you can do that comparison. You compare the coefficients. So r cos alpha equals to 1. Negative r sine alpha equals to 2. Like so. Okay, so how do we solve this? We have two unknowns, r and alpha, and two equations, so we can solve it simultaneously. So what you can do is, let's say we call this equation 1, we call this equation 2. We can take equation 2 divided by equation 1, which is going to give us negative tangent alpha equals to 2. So now we can find tangent alpha. Okay, so arc tangent, take the modulus of that. So we're putting arc tangent 2 Remember, the straight lines means the modulus. So you're only taking the positive value because we are interested in finding the principal angle. So we're going to get 63.4 degrees. This is the principal angle. And now we use the cast diagram. And you can see that this is actually a negative tangent, right? There's a negative over here, which means we have to pick the second and fourth quadrant. Therefore, your answer is alpha is actually 180 minus 63, which is 116.6. And the other one is 360 minus 63.4, which is 296.6 degrees. Okay, so once you have done that, you can actually use this to find R. So R cos 116.6 degrees equals to 1. Therefore, R must be 1 divided by cos 116.6. You will get negative 2.23. What if you use 296.6 here? You will still get the same thing because cos 296.6, actually no, you wouldn't get the same thing. You will get a positive value for R. So R would be positive here instead. So R could be this, or if you use R cos 296.6, then this one would give you 2.23. So typically for questions like that, they will tell you what the angle alpha is. So they'll tell you that alpha is between 0 to 180. So you want to use this one, which means you would get this one. So it kind of depends on the question. So let's say we use this one. You know what? Let's use this one actually. Let's use this one, which means our R cos theta plus alpha is actually going to give us 2.23 cos theta plus 296.6 degrees. So depending on which alpha you use, you have to use the corresponding R. Okay, so let's say we use this alpha, so we're going to use this R. So I'm going to get this guy instead. So once you have gotten this, you can see that this thing is actually equals to this. So you can actually just replace this with this, and that's going to give you 2.23 cos theta plus 296.6 degrees equals to root 2. So now this is actually a form that you can solve quite easily because you would actually get cos theta plus 296.6 degrees equals to root 2 over 2.23. Which would give you 0.634. So theta plus 296.6 is going to give you a cos of that, which will give you 50.6 degrees. This is your principal angle. So looking at your cast diagram, you want to pick this one and this one because it's cos. Okay, so we have 50.6 degrees and 360 minus that, which gives me 309.4 degrees. So our theta is actually 50.6 minus that, so 296.6. So we get 12.8 degrees. 50.6 minus 296.6 gives me negative 246 degrees. And then depending on the domain of the theta they've given you, Usually the theta is between 0 to 360, which means you would have to rule out this first answer. So your answer would just be 12.8. Okay, so if theta is between 0 and 360, therefore your answer is 12.8 degrees. For example. Essentially, that's it. But let me just do a couple of questions just to give you a better idea of what to do. So let's go to the past years and try some questions. Okay. Let's try this one. Wait, actually, not this one. This is not the kind of question I want to discuss. Which one is it? Ah, yeah, this is the one. Question 1. All right, so if you look at part A, it says by first expanding this guy, express this minus this in the form of r cos x plus alpha. So usually they will tell you which form they want you to use. Sometimes they will say r sine x minus alpha, or they'll say r cos x minus alpha. And you just have to rearrange and compare the coefficients with the correct sign. So let's say they give you something like this, find the value of r in 4 significant figures and the value of a correct to 2 decimal places. And they tell you that alpha should be between 0 and 90 and r should be greater than 0. So you have to choose the value of alpha such that it fulfills these conditions here. Okay, so we have r cos x plus alpha. So you want to work backwards. You start with this, expand this, so that's going to give you r cos sine, rearrange it so that all the constants are grouped together. Okay, and then now you compare the coefficients, so you see that we have cos x plus 45 degrees minus square root of 2 sine x. So if you compare the coefficients, you see that this is actually equals to 1. So 1 over here. Oh wait, actually no. This is a bit different. You see this guy is not cos x. So you have to make sure this guy is actually cos x first. So we're going to have to expand this a bit. All right, so let's do that. This is actually cos minus sine. Okay, so what do we have? Cos 45 is root 2 over 2. Sine 45 is also root 2 over 2. Okay, now I'm going to group the sine x's together. There. Let me just rearrange this a bit. Now, if you look closely, you'll see that this guy here is the coefficient of cos x, which is the same as this guy right here. And this guy here is the coefficient of sine x, which is the same as this guy. Okay, so we want to compare these two things. So we have r cos alpha equals to root 2 over 2. And then negative r sine alpha equals to negative root 2 over 2 plus root 2. Okay, and then let's say we call this 1, we call this 2. So the next thing we want to do is you have to find the angle first. So we take 2 divided by 1, which is going to give us negative tangent alpha. The r's will cancel. And then we have negative root 2 over 2 plus root 2 over root 2 over 2. And then you simplify this and see what you get. Right, so you end up with 3. Therefore, alpha should be the arctangent of 3, which would give you 71.6 degrees. So usually this is the principal angle and you have to do the cast diagram, right? But if you look at the question, alpha is between 0 and 90. So we don't have to worry about the other angles in the cast diagram because we're only interested in the first quadrant. So that is actually our answer already. So we can stop there. So once you've gotten your alpha, you have to find r. So we're going to substitute this. Substitute alpha equals 71.6 into either 2 or 1. I'm going to choose 1. So we're going to get 71.6 equals to root 2 over 2. So you should be careful here, and instead of using 71.6, you should use the unrounded figure in your calculator, because if you use the rounded figure, you're going to be rounding off twice, which would give you which might give you an error, so you might lose the accuracy mark at the end. So you should use the unrounded value when you put it here. Okay, so r is going to be equals to cos of the answer, and then we take root 2 over 2 divide by the answer, which gives us 2.24. There. R has to be correct to 4 significant values. So hang on, let me just change this. So this should actually be 2.236 for SF. This should be 2SF actually. So let me just change this to be 2SF. Oh, 2 decimal place. Oh, whoops. This should be 2 decimal place. My bad. Hang on. Arctangent 3. So this should be 71.57. There. Okay, so that should be your answer. Okay, you guys good? You always start from the r cos something that they've given you and you expand it from there, and then you compare with your existing equation. But you have to make sure that it looks exactly like the expanded form of the r equation. Okay, so next one, hand solve the equation, blah, blah, blah equals to 2. So in order to do that, you just use the r form of the equation that you got earlier. So this is part A, this is part B. Yeah, you get -3 if you include the negative here, but there's also a negative here. So when you move the negative over, it becomes 3. Then -√2 sin x equals to 2. So this guy, we can actually write this as r cos something, right? The one we got earlier, which was this r cos x plus alpha. And we've actually found what r and alpha is. So r is actually 2.236 cos x plus 71.57. And now we can solve this. Okay, so 26.6 degrees. This is your principal angle. I'm going to use the cos diagram here. You can see that this is a positive cos, so you want to pick the first and fourth quadrant. Which is going to give us 333.4 degrees. Therefore, x is going to be... actually, we might want to do one more. So 26.6 plus 360 gives us 386.6. Okay, so we're going to do all three. You can actually do as many as you want, but in the end, you have to choose the answers that are between 0 and 360. So now we're going to subtract all these values by 71.57. So that's going to give me negative 44.97. $261.83. And finally 315.03. And as you can see, we have to ignore this because this is not within the given domain for x. So our answer is actually these two values here. So you have to be careful because a very common mistake that people tend to make is they would forget about this third answer. So when you see that you are subtracting by a large value and the principal value is small, you want to include a third answer here by adding 360 to this, just in case this actually gives you something within the given domain. All right, if you're not sure, just do for 2 cycles, and then you just keep the answers that are within 0 to 360. Okay, so that's how you do this question. Let's do one more. Okay. So here we have cosec and cotangent, and they want to express it in this form. So first we're going to try to expand this guy here on the right. So we have r sine x minus alpha equals to √2. And they want the r to be more than 0 and alpha to be between 90 and 0. Okay, let's expand this using the addition formula for sine. So we have sine cos sine equals to root 2 . Okay, so you can see that we now have something that looks like this. You have a sine x and a cos x. But if you look at the original expression they've given us, it doesn't look anything like this. So what we have to do is we have to make this look like this. And we have to equate it to root 2 before we can continue and compare the coefficients. So let's do that. Cosec is actually 1 over sine. Cotangent is cos x over sine x. Okay, so we're going to start by multiplying everything by sine x. And then we're going to rearrange this. So we get root 3 sine x minus cos x equals to root 2. So now you can see that this looks kind of like this. So I'm going to put a 1 over here. So you can see this coefficient of sine x is actually this guy here. And the coefficient of cos x is actually this guy here. And you can see there's a root 2 in the root 2. So now we can compare the coefficients. Okay? So we compare the coefficients, you do the same thing. R cos alpha equals to root 3. Call this equation 1. And then negative r sine alpha equals to negative 1. We call this equation 2, and then we'll take equation 2 divided by equation 1. So that's going to give us negative tangent alpha equals to negative 1 over root 3. So what is alpha going to be? You will get 30 degrees. There we go. Now we're going to substitute alpha is 30 degrees into 1. Okay, so r is going to be 2. Therefore, root 2 cosec x plus cotangent x equals root 3 is actually 2 sine x minus 30 degrees equals to root 2. And done. And they ask you to solve this equation in part 2, so we just solve it normally. Right, so this just becomes root 2 over 2. Arc sine of that gives me 45. So this is your principal angle. So using your cast diagram, because this is a positive sign, you want the first two quadrants. So it'll be 45 and 180 minus 45, which is 135. And then you're going to add 30 degrees to each of them, which gives you 165, and then that's your answer. There we go. Finito. Okay. That's essentially it. I think I'll do this one. This one here is a little unusual, so I think I'll do this just to show you what to do. Prove the identity that cos 4 theta minus this equals to this guy here. Right. So this one actually involves the double angle formula. You can start from the left-hand side or the right-hand side. It's up to you. But I think it's easier if you start from the left-hand side. So you want to use the cos double angle formula. So remember cos to x is equals to 1 minus 2 sine squared x, or 2 cos squared x minus 1, or cos squared x minus sine squared x. So I think you want to use the first one, because you can see on the right hand side you only have sine. However, if you look at this, you see that this is actually 4 theta and not 2x. So what can you do? Well, what you can do is you can write it like this. Cos 2 times 2 theta. So now this is actually kind of like a double angle formula because it's 2 times x, right? So if you have, let's say x is equals to 2 theta, then you would get cos 2 times 2 theta equals to 1 minus 2 sine squared 2 theta. So that's what we are going to do. And then here you have cos 2 theta, so we're gonna write that as that. Okay, and then now we have to use the double angle formula for sine. Wait, let me think. All right, let's simplify this a bit first. Okay, so we have the minus 3 at the end. So we have to simplify this so that this becomes 8 sine to the power of 4 theta. So we need to get rid of this 2 theta. So how can we do that? Well, you can do it like this. Remember, whenever you have sine n x, it is actually the same as sine x to the power of n. They mean the same thing. Okay? So sine 2 theta, what is that? Hey, Elise, hello, morning. Sine 2 theta. Sine 2 theta, for that, you have to use the double angle formula, which is actually 2 sine theta cos theta, like that. So we're gonna chuck that in here. There we go. And you're gonna expand this guy, which is gonna give you 4 sine squared theta cos squared theta. But we want to make everything in terms of sine theta. So we have to get rid of this cos squared theta. So the way we get rid of the cos squared theta is by using the basic identity, the one that you've done in AS. Something like that, right? So cos squared theta is 1 minus sine squared theta. And we're gonna plop that into this guy here. So that's gonna give me, let's see, 2 times 4. You know what? Let me just write it like that. 1 minus sine squared theta. So expanding this guy, we're going to get 8 sine squared theta plus 8 sine 4 theta minus 3. So these two would cancel, and then you're left with our answer. Ta-da! Ta-da! There we go. Finished. So, yep. That's it, really. There's nothing else to talk about, I think. Though, a lot of these questions you have to actually practice to really know what to do. So, a lot of this, I would say 90% of this depends on you actually doing the questions and attempting it yourself. So I'm gonna expect a lot of questions from you guys next class, and then we're gonna discuss the ones that you're stuck on, because chances are you're going to be stuck on a lot of these questions. So anyway, that's it really. I don't think I want to start a new chapter today because I would rather you spend your time practicing on these questions. I'll send you some of the easier ones on the textbook, so you can try exercise 3D and 3E. Hang on, let me just have a look. Yep, you can actually try all these questions. So you can start with exercise 3D and 3E. After that, you can start doing the past years. I highly recommend doing at least half of the past years, because the exercises are actually a bit too easy and it's not really reflective of the kind of questions that you get in the actual exam. So, okay, we'll stop here for today. Next week, we're going to start with differentiation. But before that, we're going to go through the questions that you guys are stuck on. So please send me all the questions that you need help with over the weekend, and we'll go through that next week. Okay. So,
nice.
Yeah. Just because we are stopping early today, doesn't mean you can just do nothing for the rest of the next 1 hour or so. Please attempt the questions and get back to me if you're stuck. Okay. All right, we're gonna stop here. I'll see you guys next week. Those of you who are taking physics, I'll see you tomorrow. All right, that's it for today. Bye-bye.